triangle as height. So we're not going to get a protractor out or anything. We're just going to draw an altitude from angle C as straight down as you can and make a right angle. Okay? We're going to label the different parts of this triangle because we're going to take this triangle and come up with the law of cosines, which you can use on any triangle. But again, we're going to prove it from the triangle using the two right triangles inside, because used to be, I told you, you couldn't use cosine or sine or anything unless that was a right triangle, which is true, but we're deriving it from two right triangles, D, C, B. And where did I get those? Correct. Now we're still going to need these two pieces right here, so we're going to label this piece right here X. If that's true, how could we express this piece? C minus X, correct. C minus X. Okay? All right, now we have it all labeled. We can go do this now. All right. Here we go. So the first thing we have to do is express the cosine of B, and we're going to just do it considering this right triangle right here. Cosine is what over what? X. Ca. Adjacent over hypotenuse. So this is X over D. Do you? Okay, so we've expressed cosine of B right here with that right triangle. Now we're going to take and we're going to solve for X in this cosine. So what do I multiply both sides by? By D. X equals D times the cosine of B. This we will need later, so let's not forget about it, okay? All right. Use the other half of the triangle and write the Pythagorean theorem for that triangle and start substituting. Well, we actually have to write the Pythagorean theorem for both of these triangles. Oh, I forgot to put the H here. That's our height. That's our height. Okay. So we're going to start with the small triangle and write the Pythagorean theorem. Small right triangle here. So the Pythagorean theorem would be small right triangle. That's what it's supposed to say, small right triangle. Okay. So the hypotenuse is D, right? So we're going to say D squared equals the legs each squared. So I'm going to write this. That's the small right triangle expressed in the Pythagorean theorem. Then we're going to do it for the large right triangle, same thing. We're going to express this larger right triangle using Pythagorean theorem. So it's the hypotenuse squared equals the height squared plus C minus X squared. See it? Okay. Now we're going to work with this, but we have to use this and plug it into here. So what we need to do here is we need to solve for h squared. Solve for h squared, which means we subtract x squared from both sides, and it looks like this. So I just solved for h squared there so that I could substitute it into here. Because there's an h squared here too, isn't there? So I take this, and I'm going to put it into here. Let's see what that looks like. B squared equals D squared minus X squared, and I still have this thing, right? So before I write anything else here, let's think about what this means. This means C minus X. You don't have to really necessarily write this, but that means that, right? So we got to FOIL that. So what's the first thing? C squared. C times C is C squared. Then we do C times negative X, which should be just negative CX, let's say. And we're going to combine that with another negative CX. So how many CX's do I have? Yeah, minus 2CX or XC. It doesn't really matter how you write it. What's at the end? X squared. Okay, now let's take a look at this. Maybe we can simplify. What can we do? Ah, the x squareds cancel out. Okay, cool. Now, I see a b squared, a d squared, a c squared. I see a c. What's the odd man out here? But what does x equal? Oh, so we can take that and we can put it in here for x. Okay? So it looks like this. B squared equals D squared plus C squared minus 2 times C times D. Just hang in there with me. I promise it'll get better. We're really close now. Actually, we're there. This is it. Now, let me show you. It's not as confusing as you might think it is. Okay? So if I redraw, I'm going to redraw this, kind of try and redraw this triangle up here. It's not beautiful, but this is D, this is C, this is B. Oh, what do you notice here? Let's say we have B squared on the outside, right? B squared on the outside of the equal sign, right? Look what's on the other side. We have the other two sides, D squared plus C squared minus 2C times D. That's all these two sides, right? And then you just multiply it by the cosine of the angle opposite the side you might be trying to find. It'll get, I swear, we'll keep doing it. It'll get really clear, okay? So this is all showing you how we get this. This is actually the law of cosines right here. Turn it over and let's do it again. We'll write these out. We're not doing it again. We're going to write it out. Draw a picture up here. A, B, C, A, C, B. Okay? Now there's 3 ways you may see the law of cosines written. The letters mean nothing really. Okay? You could have X, Y, Z. It doesn't really matter. But we're just working with A, B, C here. So let's say we're going to have A squared on the outside of our equals by itself. What goes in here are the 2 other letters squared, right? Remember that? So it would be, let's say, B squared plus C squared. Then we had a minus 2. Remember, I don't know if you remember, but I'm telling you. And that 2 is multiplied by B and C, whatever these 2 are. Then we multiply all of that by the cosine of the angle opposite the side you're trying to find. Cosine A. Okay? Let's do B squared. Okay, if we're trying to find B. Okay, if we're trying to find B, what 2 letters are going to be here? A squared and C squared minus 2 what? AC times the cosine of what? B. Okay, you do C squared on your own. Yes, yes? See, it's not too bad, okay? Not too bad. All right, so we're going to use this. Let's do it. We have a triangle, right? Do we have ABC? No, but does it matter? No. E and D, we're going to write E and D. Can we use law of sines with what we've been given here? We cannot use law of sines with what we've been given. We need to know an angle and one of its opposite sides, and we do not know that, do we? So we have to use law of cosines to start. So, what? That's for area. Yeah, not to find any unknown stuff though, other than that, right? So we're going to use law of cosines to find f. So I have f squared here, right? Okay, that's going to equal the other two sides squared. It doesn't matter what order you put them in. Minus 2 times what? Times 12 times 9 times the cosine of the angle opposite the side you're finding. Okay, this is just a calculation you can put on your calculator. So I want everybody to get a calculator and see what you get for this. 8.7. Are we good? We should use squigglies, shouldn't we? Okay, now I have a question for you. We have this side now. Do you think it would be easier to use law of sines or law of cosine again to find some of the angles? I would say let's use law of sines. It's a little bit easier and quicker because we have this angle and we have this side now. So let's set up a ratio. So we have the sine of 46 degrees over 8.7. What angle do you want to find now?
E.
E? Okay. So I'm going to say the sine of E over 12. Yes? Remember this? Okay, are you going to get the angle measured just off this calculation? No, you're going to have to use inverse. Okay? Did you guys get a negative number? I've not done this before.
But you did sine 46 times.
So we can subtract from 180 and get the final angle up here. So that would be, I think,
97.2.
tell me what it is because I didn't do it. 90, what'd you get?
1.2. I got like 1.1.
Okay? Are we done solving that one?
Yes.
Okay. We're going to see something a little different in this next one. So, what do you notice here? There's no angle measures. So we have to find the angle measure, which we can do. Are you ready? It doesn't matter what we start with. We have to, let's label here. This is B, this is C, this is A. Let's just choose A. So I'm going to start with this A squared on the outside of my equation. So it's going to be 4 squared. Remember, this is A. Okay? So here I'm going to have B squared and C squared, correct? So that's what I'm going to do, B squared and C squared. Then I'm going to do minus 2 what? Times what? 6 and 5, correct? But I don't know the angle measure, so I just have to write the cosine of what angle is it? A, yeah, because we started with A here, so we're using the cosine of A here. Now it becomes kind of a big, ugly algebra problem, but it's not that hard. What you have to do is be careful, though. Third hour was trying to go straight across, and you can't do that. You have to do order of operations, okay? So what I would always do first is add these two together. That's 36 plus 25. What is that? 61. So I'm going to write this here. Minus 2 times 6 times 5. 12 times 5 is what? 60. Now this is just a little algebra problem here. This is your unknown x, right? That's your unknown right there. So you have to solve it like an algebra equation. You have to subtract 61 first. Because they are not like terms. There is no cosine A here, is there? Now look at it like this. If this was an x, there would have to be an x here for you to subtract, wouldn't there? And there is not. So then you divide by negative 60. And the cosine of A is equal to what? Okay. Is that what we want? We want what? What do? We use the inverse. We use the inverse. So we're going to use cosine inverse to get the measure of angle A. And what'd you get? Measure of angle A is 41.4 degrees, almost. Okay, you would have to do that again with one of the other angles, but I think you get it at this point, right? So let me just tell you what they are. Angle B is, if I can read my writing, 82.8 is supposed to be. And then angle C is 55.8 degrees. But ultimately, you would have to do this again for one of the other angles. Make sense? Alrighty, that is law of cosines.